Okay, last problem on the June 2016 exam. Just ran out of time on the other video. I've got a 30-minute time limit, so didn't want to get this started. This could take a little bit. All right, so what we have is a water glass that is modeled after a truncated right cone. Basically, they're showing right here, if this were to continue, it would be a cone. Or in other words, you could look at it as one big cone and then take away the smaller cone. So, all right, pretty neat here. Diameter of the top of the glass is 3, so let's put that inches. Okay, 2 inches for the middle one. And okay, the height of the cup here is 5 inches. All right. Now the base of the diameter 2 must be parallel to the base with the diameter of 3. Why? To find the height of the cone. Okay. Well, one of the things we could take a look at is what would happen if we went through here and we're going to try to tip it. So let's say we go from here to here, okay, with our circle. So it's tipped, like this, okay. So what we would have, it looks like, is we would not have a right circular cone. And you've got, I don't know, that's going to be a little strange here. It looks like this portion of it, right, and this portion of it, you're going to have different amounts there. I think it's going to get pretty ugly. The other idea with height, all right, if you're talking about height, or altitude, height must be perpendicular to the base. Well, in this case, here's what we have. Right? In this case, we have, right here, we have 2 bases. That are circles. So to talk about the height, we need to be perpendicular to both. So we need a segment perpendicular to both at the same time. All right. So for one line to do that, okay, so for one segment to be perpendicular to two different circles, those circles would have to be parallel to each other. As you can see, if we're at a right angle with this one, let's say, right? So we're at a right angle with this base. If we try to get a height here, we wouldn't be at a right angle there. In a height, you should be able to move along here anywhere along these bases and get the same number. If we moved along here, we wouldn't have the same number for the height as we go through it. So there's a lot of reasons. I assume that's going to be good enough to get the credit we need for this. So, all right, we've got to determine and state in inches the height of the larger cone. What we see here is pretty tricky. We have to look at kind of what we call a cross-section of this cone. So basically what I mean by a cross-section is we're going to slice right down through the middle of it, and what you see in a 2D shape is we have this going on right here. And this would be perpendicular as well. Okay, so we're going through the height right here. So we're just taking this portion right there. Okay. Now, from here to here is the 5 that we were speaking of. Be really careful on this problem. the whole radius, or whole diameter, I'm sorry, was 3. So what we have right here is 1.5. Okay, the whole radius, or the whole diameter there was 2, so this is 1. Okay, so let me just draw that again so it looks a little better. So we got 1.5 there, 1 here, and from here to here is 5. All right, we want this distance, we'll call it h. That would make this h minus 5. And since these are triangles that are similar, we have corresponding sides proportional. All right, so how would that work? We've got, let's go with the corresponding sides here with these two, okay? So we've got 1.5 is to 1, so bigger triangle to smaller triangle should equal h, right? That height of the bigger triangle over h minus 5. I got to be careful. The 5 really isn't part of the, proportional sides. So it's just being used to get that expression. All right, so we'll cross multiply. H equals 1.5 times h minus 5. And not the ideal situation here, but I'm going to try to go least steps possible. We'll get some negatives, but that's okay. Whoops. Negative 0.5h equals negative 7.5. And divide by negative 0.5. We get a height of 15. Let's remember, since our height is 15, let's answer that portion of it. Okay, so the height of the larger cone is 15 what? Inches, right? So inches. All right, so that's an answer that we were after. Now we need the volume of the water, just a water glass. Okay, so what I'm thinking is we will calculate the volume of the big cone, and we'll take away the volume of the smaller cone. All right, so this one's 2 with a radius of 1. This one's 3 with a radius of 1.5. We've calculated this height to being 15. What's this height? Well, it's h minus 5, so t minus 5 is 10. All right, so we're going to put a 10 there for that height. Now, if we subtract these, right, you'll get the leftover is the truncated water, or truncated cone or water cup. So let's go through and do this. So the volume of the larger cone, 1/3 pi r squared h. Volume of the smaller cone. So same formula. All right. Be careful here. Make sure we've got the pi r squared 1.5 squared times 15. And for this one, let's make sure we get a 1 squared there and 10. All right. So if you let your calculator do some of this work here, let me just open up to it. Yeah. For the larger one, I got a calculation of 35.3429, so forth. Volume of the smaller, I get 10.472. All right, so the volume of the glass is simply going to be, subtract these. And I always, I don't round until the very last step. I know it says to round to the nearest tenth, but I don't do that to the last step so that I don't have any, accumulation of rounding errors. Okay? Not that I'm going to round wrong. What I'm saying is every time you round, it has a degree of inaccuracy. So when you do this at the very end, now you have a more accurate answer. So inches cubed, and that's what we're looking for. So looks like we answered all the parts, right? Okay, and that ends this session. Thanks for joining, and we'll get the next one up in a week or so. Thanks so much. Bye. Bye.